When we decide it is time to lose weight, the first instinct is almost always to start running, and it makes sense. Pounding the pavement or grinding on an elliptical burns a high amount of calories while you are actively doing it. But an exclusively aerobic routine creates a physiological vacuum. As the scale drops, you are stripping away lean muscle tissue right alongside the body fat. Over time, that loss of muscle mass lowers your basal metabolism, meaning your body burns fewer and fewer calories just to stay alive. To fix the underlying math of how your body uses energy, you need heavy resistance. Specifically, you need the deadlift, a primal, full-body hinge movement that acts as a metabolic Trojan horse. Researchers recently put endurance running and heavy resistance to the test. They built a miniature gym for mice, comparing treadmill running to a squat-like lifting movement that mimicked heavy resistance training. After 8 weeks on a high-fat diet, the resistance-trained mice displayed significantly higher insulin sensitivity and lower total body fat than the runners. Changing your body composition requires burning calories today, but it also requires reprogramming your metabolic engine for tomorrow. Pulling heavy weight off the floor demands massive mechanical effort. A single deadlift forces your gluteus maximus, hamstrings, quadriceps, lats, traps, and erector spinae to fire all at once. This chart breaks down exactly what that full-body engagement costs in terms of energy. For a 160-pound person performing standard strength training, a 30-minute deadlift session burns roughly 230 calories. That works out to an active burn rate of 7 to 9 calories per minute. If we alter the training style and shorten the rest periods into a vigorous circuit-style routine, the continuous metabolic demand pushes that expenditure even higher, spiking to 11 calories per minute. But the real advantage begins after you drop the bar. Moving near maximal loads causes microtrauma to your muscle fibers and depletes cellular energy stores. To repair that damage, your body is forced to work overtime. This is known as excess post-exercise oxygen consumption, or EPOC. Looking at this line graph, we see the immediate calorie burn from the workout itself. But notice this long tail extending to the right. That represents the EPOC effect, which forces the body to burn an additional 6 to 15% of the total workout calories over the next 24 to 48 hours. The deadlift effectively turns the human body into a continuous calorie-burning furnace. The fat loss window remains wide open for days. Zooming in past the temporary calorie burn, we find long-term physical adaptations taking place deep inside the muscle tissue. When you perform a high-intensity resistance movement, your muscles use glucose for fuel. The physical demand of the lift actively pulls excess sugar directly out of the bloodstream to feed working fibers. Repeating this process consistently improves the way your cells respond to insulin. As your overall insulin sensitivity rises, your body begins to actively shed stubborn visceral belly fat. You are left with dense, metabolically active tissue. Because this muscle requires constant energy to exist, your basal metabolic rate stays elevated, allowing the body to burn more calories even when you aren't training. Adding lean muscle through heavy lifting builds physical strength, and in the process, it changes the biological rules of how your body processes and stores fuel. These metabolic rewards come with a strict requirement. You must adhere to the physics of the lift. If you ignore the mechanics, you invite catastrophic injury. The entire movement relies on a braced neutral spine. The objective is to drive through the floor with your legs to stand up. If your lower back rounds, the structural integrity of the lift collapses. This schematic illustrates slack in the system. An overly wide stance ruins your balance and sidelines key leg muscles. Proper alignment ensures a tight system, forcing the energy load directly into the powerful glutes and hamstrings, rather than straining delicate joints. Poor technique risks a blown disc. Worse for your goals, it short-circuits the exact muscular tension needed to trigger the metabolic demand for weight loss. To structure a deadlift routine specifically for fat loss, the data points to a precise protocol. You want to use moderate loads, roughly 65 to 75% of your maximum, and aim for a higher volume of 15 to 40 total repetitions across a session. This volume threshold provides a massive, continuous metabolic demand. It keeps your heart rate elevated while minimizing the sheer nervous system fatigue and injury risks associated with heavy powerlifting singles. As noted in this review from the Journal for Sports Neuroscience, the most effective path forward is a truce. The evidence confirms that combining aerobic exercise with heavy resistance training is the most efficient way to reduce fat. Cardio helps strip the fat, but the deadlift ensures the muscle underneath is preserved. It guarantees that as your overall weight drops, your metabolism remains high. The deadlift is not an exercise reserved for powerlifters. It completes the weight loss equation, preserving the lean mass that keeps your metabolic rate high as the body fat disappears.